Self-practice 1.3a. Write in the form of variation and in the form of equation for each of the following combined variations. So they ask you to write in the form of variation, meaning that the relation varies directly as or varies inversely as, or the combined one. And then in the form of equation. So for the first question, A over here, W varies directly as the cube root of V. So the first one here, you refer to the answer that I've written for you already. Okay, W varies directly as the cube root of V, this part. Okay, and then when you see the x squared below, meaning that it inversely as the square of x. Okay, so this one, the first one is to represent the form of variation. And then you just write down in the form of equation. Therefore, W is equal to K times cube root of V over x squared. Just add on the constant here. Okay, for the second question, make it smaller. B, F varies directly as G and H cube and inversely as square root of T. So this is the answer. You check out whether you got it right. So in the form of equation, you just need to add on the constant in front at the numerator part. So that's the answer you check out. For question C, the acceleration of an object A varies directly as the distance traveled S and inversely as the square of the time taken. So the square of the time taken is T squared by the object. So this is the answer. Then change it to the form of equation. A equal to Ks over T squared. This one. Okay. Then I ask you to do question number 4 also. So now we look at question number 4. I move the answer down here first. Okay. In question number 4, they show you that the table, okay, changes in 3 quantities, which is T, E, and F. It is given that T varies inversely as the square root of E and cube of F. So I write it down like this. Okay, look at this one. This is what you should have. After that, change it to the form of equation. So the one replaced with K, the constant. Calculate the value of A and B. So you have A and B here. Okay, so what we do is, over here, I use the proportional method, whereby the constant is always the same. Therefore, I multiply T with the square root of E F cubed. Therefore, this part will be T1, E1, F1. So I have T1, E1, F1. You follow this? But then all of it is 1, 1, 1. Then in order for you to find the value of A on the right, so just replace it with T squared and then square root of E2, sorry, not T squared, T2, square root of E2 and F cubed, but it's F2. So from here, you multiply straight away. 5 times 144 times 2, square root of 144 times 2 cubed, you substitute everything, is equal to the A times square root of 36 times 0.4 cubed. Everything is the same. Okay, so just press your calculator, then you will get 48 is equal to A times 0.384. Where is the answer? Okay, never mind. The answer is not here. So let's show the working. Okay, for what we have just now, to find the value of A is equal to 48 divided by 0.384. Then you will get A is equal to 125. It's not very clear. I need to change it back. Okay. A equal to 125. So this one is A times, I missed out the question already. A equal to 125. Okay, so we solved the first one already. Then for the second one, we are going to do it the same way. You just refer back to the table here. Okay, meaning that for the 8, you already got it right just now, right? Which is T1 times square root of E1 F cubed 1 equal to T3 square root of E3F cubed, also 3. So this part, you already got the answer, which is 48. Just replace it directly. And then the T3, you follow whatever is given here, which is 0.256 times square root of E3 is B. And then you replace the F with 5 cubed. So we are going to find out the value of B, which means the square root of B is equal to 48 divided by 0.256 times 5 cubed. Okay, so over here, we are going to press the calculator. 48 divided by, in bracket, 0.256 times 5 cubed. 5 cubed is actually 125, right? If you have already memorized it. Okay, so the answer is 3 over 2. Equal to 3 over 2. That is your square root of B. So in order for us to get the B only, you have to square on both sides. So that is cancelled. Clear? Therefore, this one, the answer to the power of 2, you press, then you will get 9 over 4. But it is in improper fraction, right? So you just change it to a mixed number or a decimal. So in decimal, it is equal to 2.25. That's the answer for this one. You get it, class? Everybody get it?
Yes.
Yes.
So we continue with the next one. Okay. Next one is self-practice 1.3b. So you turn to your self-practice 1.3b. Only 2 problem solving given. So let's go through this. Mr. Kamal wants to install rectangular tiles in his room. The number of tiles needed, J, varies inversely as the length, P, and the width, L. So we have this. Of the tile used. Mr. Kamal needs 120 pieces of tiles if the tile is 0.4 meter in length and 0.5 meter in width. So you replace it, change it to equation. So J equal to K over PL. Replace the 1 with K. Therefore, you substitute everything that is given. 120 equal to K over 0.4 times 0.5. So do the calculation, you will get the value of constant is equal to 24. Hence, the J is equal to 24 over PL. You get this. Okay, now we go to question A. Calculate the number of tiles needed if the length is 0.2 meter and the width is 0.3 meter. So you follow this equation that you got just now. Replace the length and the width as 0.2 and 0.3 like this. Okay, therefore you calculate it using calculator, you'll get 400. And for B, if the area of the tiles increases, what is the change in the number of tiles needed? So when the area of the tiles, which one is the area of the tiles? Can you see which one is the area of the tiles?
PL.
Yes, very good, because that is length times width. Length times width is PL. If the area of the tile increase, what is the change in the number of the tiles needed over here? Therefore, when you see 1 divided by 1, 1 divided by 1 is a 1, right? If I increase the number, becomes 1 divided by 12. What will happen to the value? The value will?
Smaller.
Yes, decrease. Therefore, this is how you answer it. If the area of the tiles increases, then the number of tiles needed, this one will decrease. Okay, we move to question number 2 right now. Okay, question number 2 is very long. The average number of daily phone calls C between 2 cities vary directly as the population of 2 cities, P1, P2, and inversely as the square of the distance. So C is equal to P1, P2 over J, like this. And then you change it to the form of equation. So you will have C equal to K P1, P2 over J2. Okay, the P1, P2, remember, is not the square, it's just to indicate the 2 cities, P1 and P2. Okay, now the average number of daily phone calls between the 2 cities is 15750 And the population of city A and city B are 105000 and 220,500 respectively. Give your answer correct to the nearest whole number. So substitute the telephone call into C. Substitute the population of city A and city B with this. Okay, and after that, the distance between the two cities is 210. So your substitute becomes 210 squared because you follow the formula. Then you find the value of K. So the value of K is 15750 multiplied by 210 squared divided by 10500 times 220500. Okay, so hence C is equal to 0.3 P1, P2 over J2. That is the formula that we get from the calculation. Okay, now we can answer the A already since you already got the formula. The distance between city P and Q, they want you to find if the populations are 83400 and 62,000 respectively, and the average number of telephone calls is 19151. Actually, there is a mistake in this question. Did you all check with the answer at the back whether you got the correct answer or not?
Yeah.
Is the answer at the back correct? It's different, right?
I got 90, madam.
It's 90, madam.
It's
Yes,
90. It's different. Okay, so we go back to this first. We substitute everything. 19151 equal to 0.3 times x is 3,400 times 62,000 over j squared. So you need to find j squared, right? J
Madam,
squared. Yep.
I think you did a mistake when finding the constant.
Is it? My constant is not correct, huh?
Is the 10,500 supposed to be 105,000?
Oh, yes, thank you very much. I missed it out. Okay, so what is the new constant that we get from here?
0.1 is 0.03.
Thank you. Thank you very much. So this one we replace with 0.03. Okay, thank you very much. 0.03, and it will be correct already. Okay, so this one is 0.03. Okay, so the J will be 8,100, correct or not? Correct or not, class? Therefore, you'll find out the square root of 8,100 will be equal to 90. Okay, that's correct already. 90 kilometer. Okay, that is for A. And then for B, the population of city J, if the population of city K is 1,100,000, with the distance between the two cities is 351 kilometer. The average number of telephone calls between city J and city K is 18,857. So we got to replace this one already with 0.03. Okay, so you substitute everything into the value of C. The number of phone calls is equal to 0.03 times this one, in bracket J times 1,100,000 over 351 squared. So from your calculation, okay, my value over here will be changed already. It is equal to 70,400 kilometer. Is that correct, class?
Yes, madam.
Yes, madam.
Yes, madam.
Good. Do you have any questions so far?
No.
No, so we continue with the new chapter today, which is chapter 2. Okay, chapter 2 is about matrices. Hopefully some of you already go through a few pages of it. Okay, we look at chapter 2, matrices. In this chapter, what you are going to learn okay, chapter 2, matrices. So we go through briefly what you will learn in this chapter. There are only two subtopics. The first subtopic is about matrices, and the second subtopic is basic operation on matrices, whereby you are going to plus, minus, multiply, and divide, and then you are going to find the inverse and so on. So today we are going to learn matrices first. Okay, why do you study this chapter? Okay, if you can see here, matrices are used in the field of mathematics to represent and solve problems in algebra, statistics, and geometry. In daily life, it can be used by a purchasing manager to record the amount of inventory in his business. So the mathematicians here that developed the theory of matrices is Arthur Kelly. Okay, Arthur Kelly. You can go through this one. I think we just skip this part lah. Hopefully you can go through it yourself. Okay, now this one also I think you go through it yourself lah. According to a digital report 2018, the total number of internet users has reached 25.08 million and so on. Yeah, it's very long. Okay, we go straight into the matrices now. Okay, 2.1 matrices. How to represent the information from real situations in the form of matrices. So if you look at the question given here, Kedai Electric Sinajaya records the sale of 3 types of fans in a spreadsheet. The diagram below shows the in-store and online sales of the fan for the months of March and May. So you can see March to May, April, May. Okay, and then this is the total sale of March and April, and then the difference in sale between April and May. Okay, how can this data be arranged? So we arrange this data by using matrix. Okay, so we look at the first one here, they enlarge it, becomes this, whereby in-store the number of stand fan is 16, ceiling is 18, wall is 11, and for online store, they have the number of fan is 5, 10, and 4. So we just replace all of it in the form of matrices. As you can see here, 16, 18, 11, and then 5, 10, 4 here. Okay, just like what you have learned in, if some of you took ASK, right? So in computer, we learn about rows. These are rows, and these are called columns. Rows, columns. You need to know this, Okay, what is a matrix? Here, a matrix is a set of numbers arranged in rows and columns to form a rectangular or a square array. Okay, so it forms up an array which is made of numbers lah. Okay, now you look at the teachers there. A matrix is usually represented with capital letter and written in the bracket, the square bracket or the round bracket like this. Okay, so now the historical treasure, James Joseph Sylvester, 1814 to 1897, was the first mathematician that used the term matrix in 1850. So a long time ago, we already have this matrix. Now we get into this, the next one. Okay. Example. Represent the following information in the form of matrices. A, the table below shows the recommended daily calorie intake for females by category. So this is the recommended daily calorie intake for a female child, for a female teenager, for female adult, and female senior citizen. So you can see the daily intake for a child is 1,700, not very much. Teenager is the highest one among all of it because teenager, you know, you are growing, you need more energy. Then this adult, 2,000, and senior citizen is getting reduced, okay, become 1,800. Okay, they ask you to represent the information in the form of matrices. So for this table here, you can represent it in 2 forms. It's either a row matrices or a column matrix. Okay, so you can see the given answer down here, this part. So for A, you can represent as 1,700, 2,100, 2,000, 1,800. Or you can represent it using the column matrix like this, 1,700, 2,100, 2,000, and 1,800. Okay, so this one, the one that we have just now, is called row matrix. A row matrix has only 1 row. And then this one is column matrix. Column matrix has only one column. You remember that. So we are going to learn 4 types of matrices today. The first two you already know, the row matrix. This one, column matrix. Okay, now we look at the next example. The second part. Yeah, it's very hard for me to control this. Okay, here. Okay, B. The table below shows the medal collection of Malaysia contingent for 3 events in the 29th SEA Games. So you can see for diving, the gold medal we have 13, silver 5, bronze 1. For pencak silat, we have 10 to 4. Athletics at 9. Okay, so how are we going to represent it? You can see all consists of 3 rows in 3 columns. So you just fill in everything into the matrices. 13, 10, 8, 5, 2, 8. On second column, this is the last column, 1, 4, 9, 1, 4, 9. Okay, or you also can represent it in the other way around. For example, 13, 10, 8. You can see 13, 10, 8. You represent it as a row. 13, 10, 8. 5, 2, 8. 5, 2, 8. 1, 4, 9. 1, 4, 9. Okay, when you have the same number of columns, same number of rows, and the same number of columns, we call it square matrices. Okay, so you can see here, these are the square matrices. The square matrix has the same number of rows and columns. Okay, now we look at the next one. So next one is C. Okay, I wrap this off first. Here, C. In test 1, Samad scored 76 marks for Bahasa Melayu. 76 BM. High or not high? Be moderate only, right? 82 marks for mathematics. Oh, okay, 82. But I really hope he can get 100 marks for mathematics. And 72 marks for history. While Hamid scored 80 marks for Bahasa Melayu, 88 marks for mathematics. So Hamid scored higher than Samad, and 70 marks for history, but history is lower. So we have Samad and Hamid. Okay, they asked you to represent it in the form of matrices. So we can see from here, you either represent it using the vertical method first, whereby you are going to represent the Samad's mark 76, 82, and 72 in the column part 76, 82, and 72. And then the other one, which is Hamid, he scored 80, 88, 70. So 80, 88, 70. Or you can represent it in the row format with 76, 82, 72, and 80, 88, 70. So this one, we don't have the same number of rows and columns, because for the first one, we have 3 rows, and then we have 2 columns. But then for the second one, we have 2 rows and 3 columns. So it's not even, right? When they are not even, we call that a rectangular matrix. Okay, for a different number of rows and columns. Therefore, you already learned these 4 types of matrix. The first one, row matrix. The second one, column matrix. The third one, square matrix. And the last one, rectangular matrix. Okay, now we are going to look into some of the example on how to represent from the table here. Okay. Everybody, do you have your, maybe you take out a piece of paper? Do you have a piece of paper?
Yes.
Okay,
Yes.
a piece of paper. I want you to do this right now. Question number 1. A 5th generation 5G mobile technology exhibition is attended by 857 teenagers, 3,180 adults, and 211 senior citizens. Represent the information in the form of matrix. You bear in mind for the matrix that we represent, you can either use the round bracket or you can use the square bracket. but usually we use this one. Okay, the square bracket. But when it comes to operation later on, whereby you have addition, multiplication, division, and so on, then we are going to use the round bracket outside. It's opposite from the normal calculation. Usually in the normal calculation, we are solving the bracket first, for example, plus 2 times what in bracket. And then when we want to solve the big one, so we put it in the big bracket, the square bracket like this. But for matrices, it's the other way around. So you are going to write down everything in the square bracket. But it's not wrong if you write it down in the round bracket followed by a square bracket. Okay, so for the first question, can you try it out? And then we check the answer. I give you about 10 seconds. You do it right now and then you check. 10 seconds, start from now. Done?
Done.
Okay, so you can either represent the first question in the row matrices. Okay, start from 857 and then 3180 and 211. This is the row matrix. Or you can represent it using the column matrix at 57, 3180 and 211. My bracket is not big enough. Make sure your bracket is big enough to cover everything. Yeah, hold on. Okay, make sure it's big enough to cover everything. Now we look at the second question, number 2. The table on the right shows the average air pollution index, API in Putrajaya. This one is very long time already. We have air pollution previously. Zarantut and Sandakan for 3 days. Represent the information in the form of matrix. So can you represent the information for this one in the form of matrix? I give you 10 seconds also. Very simple. You just copy down directly from the question. Done.
Yes.
Done, everyone? Okay. Done. Then, so hopefully you do it the correct way. Open up your bracket, represent it with 53. Just copy down everything exactly the same way. 52, 21, 48, 50, 20, 46. Or you can do it the other way around, which is 53, 20, 47, 52, 21, 48, 50, 20, 46. Okay, and then for the third question, okay, if you look at the table given, can you tell me what types of matrix is this? Let me find out who is available. I can't really see your face over here. Jenwell is here today. Jenwell, can you tell me what types of matrix is this for question number 3 that we can form? Jenwell? Hello, Jenwell. Jenwell, are you there? J, just now I saw you. Jenwell, you are there, right? Can you hear? Don't know where is Jenwell going. Okay, Marcellus. Are you there, Marcellus?
Yes, ma'am.
Okay, so Jenwell is there already. Jenwell, I go back to Jenwell, Marcellus, sorry, you are the backup just now. Okay, Jenwell.
It's okay.
What is the name of the rectangular? What is the name of the table here? The matrix that we can form from the table. What is the name of the matrix that we can form from the table? Jenwell, you cannot talk, is it? You have to write, is it? Jenwell, turn on your speaker and then you just answer. Can, General? Okay, I think he cannot reply us. Marcellus, go back to you. Marcellus, can you give us the answer? I mistakenly spoke the answer just now. Yeah, Marcellus.
Rectangular matrix.
Yes, very good. Rectangular matrix. Rectangular matrix. Okay, so how are we going to represent it? You can just replace it with, just copy down everything directly. 20, 18, 15, 12, 10, 11. Or you can do it the other way around, like just now this one. We have the first one and then we have the second one like this. Okay, I think you don't have problem with this one. So we continue with the next one. How to determine the order of a matrix, hence identify the certain element in the matrix. So in here, later on, you are going to find out how to determine the order of the matrix. And second thing, how to identify the element in the matrix. Okay, we look at the description here. Order of a matrix can be determined by counting the number of rows followed by the number of columns of the matrix. For example, okay, you have this one, this is row, this is column. This one, row 1, this is row 2. This is column 1, this is column 2, this is column 3. So the order for the matrix is 2 times 3. 2 to represent the row and 3 to represent the column. Remember, the row comes first, followed by column. So if you have 2 rows, then we have, you write down 2 and then 3 columns. That is the order of the matrix. Okay, so matrix with m rows and n columns has the order of m times n and is read as matrix m by n. Okay, so this one we read it as 2 by 3. Okay, every number is the matrix is known as an element of the matrix. For example, the element at the second row and third column. Second row, this is first row, this is second row. And third column. Third column, this is first column, second column, third column is 4. Okay, that is how you identify it. We look at the second example here about the name of the matrix. Capital letter is used to denote a matrix. For example, A, capital letter, is equal to all the matrix over here. And the element at the second row and third column. So you have to refer to the second row again. This is the second row. Third column, 1, 2, 3. Second row, third column can be represented as A to 3. So A to 3 equal to 4. Okay, so now I'm going to ask question here. From what we have learned, the order and also the elements. For example, if I have this matrix, okay, Hazlin, are you there? Hazlin, I want you people to answer the question right now. Hazlin, Malihi, are you there? Okay, Hasdin, can you tell me what is the order for the matrix that I've just write down here? What is the order, Hasdin? What is the order of the matrix? This is matrix what? Hasdin? Or you can't talk? Lost again. Okay, Irfan, you are here.
Yes, madam.
Okay, good. Irfan, can you tell me what is the order for this matrix?
Is it matrix 2 times 2?
Yes, correct. Very good. It's matrix 2 times 2, but then we call it matrix 2 by 2. Okay, thank you. Yes, Hazlin.
Hazlin answered in the chat just now.
Is it? Oh, matrix 2 by 2. Yes, correct. Thank you, Haslin. Me other answer. Why you cannot talk, is it, Haslin? Okay, never mind. We go back to this. Now I'm going to change this matrix into a different one. Okay, I'm going to call you again. Can you tell me what types, not what types, what is the order of this matrix? Let me see. Who is the lucky one right now? Hedy. Okay, Hedy. Can you answer me what is the order of this matrix? It is matrix.
Which one just now, madam?
This one, Hedy. Can answer or not, Hedy?
I don't quite understand, madam.
Okay, to name the order of the matrix, you remember we have to state the number of rows first, followed by the number of columns. So if we have 2 rows, meaning that this is matrix 2 by 2 rows, 2 by 1 column. Okay, Hedy?
Okay.
Okay, now I'm going to give you another question, Hedy. You answer me the order for the matrix. What is the order for this matrix? What is the order for this matrix, Hedy?
Is it 1 by 1?
It's not 1 by 1. It's 1 row by 1.
Or 1 by 3?
Yes, it's matrix 1 by 3. Okay. What about this matrix here? It's actually the same. No, I don't want to use this. I change it. Okay, no more Hedy. Thank you, Hedy. So I move to the next person now. I'm going to test you again to see whether you understand or not. This one. 1, 2. Okay, who is the lucky one? Honey. No, Honey. Are you there?
Yes,
No,
madam.
Okay, Honey, can you tell me what is the order for this matrix that I've just written down?
Matrix 2 by 4 ka, madam?
Yes, very good. Matrix 2 by 4. So hopefully everybody understand. Anyone doesn't understand how to name the order of the matrix here? Any one of you doesn't understand? You can raise your hand. No one, right? Okay, if no one, then I continue with the next one. I'm going to question you regarding the element of the matrix 4. So I repeat again, scared you don't really understand. For example, if I want to mention the element of the matrix 18 here, so the way of denoting it is equal to capital A becomes small letter a. And then you are going to look at in which row comes first. So 18 is in the first row. So it will be A1. And then which column? So this is the second column, right? So A1, 2. The answer is 18. Now, if I give you a matrix, okay, I'm going to give you 1, 5, 7, 9, 11, 2, 8, 6. This one I write down further. Okay, the order of this matrix, this is matrix B. The order of this matrix is matrix 2 by 4. Now, I want you to name me the element of B, 2, 3. What is the number? Okay. Shauki, you are there, right, Shauki? All the while present. Okay, Shauki?
Yes.
Can you tell me what is the element for B2, 3?
B23. BO2. 8.
Yes, very good. B23 is 8. Okay, thank you, Shauki. I want to question another one. What is the element for B for B for 4? B for 4. Wani, are you there? Zawani? Duru Zawani, are you there? Okay. Zawani, can you tell me what is the answer for the element for B for 4? Okay, I go back to you. You type it out, is it, Wani? What is the answer for element? Is it 6? Okay, let's go back. Is it 6? Yes, very good. Oh, sorry, not B44. I've written down wrong. B24. Sorry, Zawani. Means second column and then second row. Sorry, second row and the fourth column is 6. Okay, one more. I want to pick the lucky one. B13. Can you all check right now? B13. Okay, let's see. B13. Oh, Elika, you are here. Elika?
Yes, madam.
Elika, have you identified B13? What is the answer?
7.
Yes, very good. 7. Thank you, Elika. So no problem in identifying the order and also the element of the matrix, right? Okay, now we are going to continue to the next example here. Okay, this part. In general, the element at the ith row and jth column in matrix A can be represented as Aij like this. What I've told you just now. So all the elements, the first one, first row, first column is A11. First row, second column, A12. And then the last one, we don't know, but it is first row, n column, because dot, dot, dot here. So A1n. And then if you look at the third row, we also don't know the row over here. So it's M row, but first column, because we know it's first column. Then this one will be A, M2. This is A, M, N, the last one. Okay, now we look at the example here. I move it up. Okay, example 2. It is given that matrices P equal to 3, negative 7, 9, Q equal to 4, 5, and R equal to this. Determine the order of each matrix. So this is matrix 1 by 1, 2, 3, 3 rows. So it's 1 by 3. And then for Q is equal to matrix 1 row, 2 row, 2 by 1. And then for R, we have 4 rows, 4 columns. So the order of the matrix is 4 by 4. So you can look at the solution. That is how you answer it. The order of matrix P is 1 times 3, 1 by 3. The way we read it is 1 by 3, but then when you write down, it's 1 times 3. Okay, and then the second one, the row of matrix Q is 2 by 1 and 4 by 4. Okay, now we look at the element. The element in the first row and third column of matrix P. So you got to refer to matrix P. This is matrix P. First row, this is the only one row. Third column, so P13. P13 equal to 9. And then for the second part here, at the second row and first column of matrix Q. So I rub this off. Now we are going to refer to your matrix Q. They want Q 2, 1. This is 1. This is 1 row, first row, second row, 2, 1. So the answer is 5. And then for the third one, at the third row and fourth column of matrix R. So this is matrix R. They want the third row and fourth column. So R 3, 4. 3, 4 is you refer to 1, 2, 3, the third row and the fourth column. So the answer is 1. So the way of you answer it, you look at this. P13 of matrix P is 9. Q21 of matrix Q is 5. And then R34 of matrix R is 1. Okay. Now we look at example 3. Given that matrix D equal to the number given, so they ask you to determine A, the order of the matrix. So you can see already we have 1, 2, 3, 3 rows, 2 columns. So the order is 3 times 2. Then they ask you to determine the element of D11, D21, and D32. So 1 means first row, first column. So the answer is -2. And then for D21, second row, first column. So the answer is 0. For the third one, D32, so third row, second column. That's why it is a 9. So you just need to state D11 equal to -2. That's all. Okay. Okay. Now, historical treasure. Cuthbert Edmund Callis was an English mathematician who introduced brackets for matrices in 1913. Callis used the notation A equal to Aij to represent the element at ith row and jth column in the matrix. Okay, so Cuthbert Edmund is the one. Okay, now the next one. So self-practice, later on, I want you to do this directly. I give you the exercise. Solve all the questions in self-practice 2.1b. Whereas for 2.1a, just now we already solved it. No need to do. Now we continue with the matrix that are equal. How to determine whether two matrices are equal? Very simple. Okay, look at the two matrices below. So you're given M equal to A, B, C, D. You look at the arrangement, A, B, C, D. It's up to them how to want to arrange. Usually they will follow by row first. Usually it's row, okay, A, B, C, D. And then they seldom write like this, A, B, C, D, because row come first. Okay, so you got to remember that. Then N is equal to 1, 2, 3, 4. If they said matrix M is equal to N, then when I ask you what is the value of A, directly you refer to 1. Okay, that is how you find out whether they are the same or not. Later on, you see. Okay, look at the bottom part here. It is found that matrix M and N have the same order, which is 2 by 2. And if each corresponding element is equal, which is A equal to 1, B equal to 2, C equal to 3, and D equal to 4, then matrix M and N are equal and can be written as M equal to N. Okay? Not that this one, M equal to N if and only if both the matrices have the same order. Remember, they must having the same order, and each corresponding element is equal. Each of it. If one of the element is not the same, then they are not equal. For example, I have 1, 2, 3, 4. And then I ask you, is 1, 2, 4, 3. This one, are they the same? Because one of the elements is not the same already, right? Therefore, this is not equal. But then their order is the same. Both are having the same order. Okay, order 2 by 2. Now we look at the example to determine whether they are equal or not. Okay, example 4 here. Determine whether each of the following pairs of matrices is equal and then give your reason. So we look at A. It's always like this with my pen. Okay, A. A is equal to 2, 11, 1, 3, and B is equal to 2, 11, 1, 3. The order of matrix is the same, matrix 2 by 2, and each of the element inside is the same, right? Therefore, these two matrices are equal. Okay, and then we look at B now. C is equal to 3, 9. Okay, the order of the matrix is 1 by 2, and then D is equal to 3, 9. The order of the matrix is 2 by 1. So you can see the order is already different. Therefore, they are not equal. And then for E, the E is equal to add 3 zeros, -7, 0. So the order is 2 by 2, and F is also 2 by 2. Then we need to compare the number. Okay, to compare the number over here, you see add 3, -7, 0. But then this one is add -7, 3, 0. Each of the element, only two element is the same, add and 0. The corresponding element is the same, but then these two is not the same. These two are not the same. Therefore, these two matrices are not equal. Okay, and then the last one, G is equal to matrix 3 by 2. H is equal to matrix 3 by 2. Okay, order is the same. Now we need to compare the value of each of the element. 0.5 equal to half. They are the same, right? 6 equal to 6. Negative 1, negative 1. Negative 2, negative 2. 0.8, 4 over 5. 4 divided by 5, 0.8, correct, right? And then 12, 12. So these two matrices are equal. Okay, so you can see how do they answer it in the solution part. A equal to B because both the matrices have the same order and each corresponding element is equal. For question B, C is not equal to D because both the matrices do not have the same order. And the order of C is 1 by 2 while the order of D is 2 by 1. Okay, like what we did just now. C. E is not equal to F because the corresponding elements are different. And the last one, G is equal to H because both the matrices have the same order and each corresponding element is equal. So to determine whether a matrix is whether the matrices is equal or not, you got to remember you must highlight on the order. Order must be the same and the corresponding element must be the same. Okay, so once you find out the order is different, that means it's not the same anymore. It's not equal anymore straight away. Okay, now we move to example 5. Okay, this is example 5. It is given that, hold on. Okay, example 5. It is given that matrix P equal to X. Yeah, this one, so we have actually, this is a matrix 2 by 2, if you see carefully. And then matrix Q is matrix 2 by 2, it's the same. Determine the value of X, Y, and Z if P equal to Q. So they told you that these two are the same. When they are the same, so it's easier, you just solve it. They want you to find out the value of X. This is your X. X is equal to 5 straight away. Okay, so solution X equal to 5. And then for Y, so you look for the Y. Where is the Y? Okay, Y is here. I use different color. Okay, Y plus 1 equal to 7. So you solve it. 7 equal to Y plus 1. And then Y equal to 7 minus 1. So Y equal to 6. And then for the third one, they ask you to find Z. So 5 minus Z is right here. 5 minus Z equal to 2Z. So 5 minus 3Z is equal to 2Z. Okay, what you do is 5 equal to 2Z plus 3Z. 5Z equal to 5. Therefore, Z is equal to 5 divided by 5 is equal to 1. Okay, so we get a 1 there. Okay, so these are all the things that covered for this morning. Okay, and then later on at home, during the tutorial time, after the tutorial time, I think I won't meet you again because I think this is enough. We will meet in the next lesson, which is on Thursday, 9:30 to 11. So I want you to do both the question here. Okay, if you are hardworking enough, you copy the question. That will be better lah. If you feel lazy to copy the question, you have a lot of homework. So for self-practice 2.1C, this one, you don't have to copy the question. Together with the exercise that I gave you just now, the previous one, this one 2.1B, 2.1B, 2.1C. Okay, now I come back to you. Do you have any question?
No, madam.
All of you understand?
Yes, understand already.
Understand.
Yes, good. So I summarize everything. Today you learn matrix. First, you learn about the name of the matrix, whereby you learn row matrix, column matrix, square matrix, and rectangular matrix. Okay, after that you learn how to identify the order and the elements in the matrix. And the last thing, what do you learn? Do you still remember the last thing? Find out whether two matrices are what?
Equal.
Yes, equal or not. Okay, these three main things only. Okay, no question, right? So I'll see you on next Next. Oh, not Thursday. I mentioned the wrong one. I teach from 1 on Thursday. I teach you people on Wednesday, 11 to 12:30. So see you on Wednesday, 11 o'clock sharp. Okay, class?
Okay.
Okay.
Okay, madam.
Thank you.
And one more thing as a reminder, please don't forget to take your attendance for today in your Google class. This one, yeah, just posted on here. The attendance for today, and also hand in your work for 1.3a and 1.3b, the one that we just discussed after you have marked it. Okay, class?
Okay.
Okay.
Okay, madam.
Wednesday then.
Thank you,
Bye.
madam.
Yeah,
Bye.
welcome.
Bye. Thank you,
Thank you,
madam.
madam.
Thank you, madam.
Thank you, madam.
Okay,
Bye, madam. Thank you,
Bye.
madam.
madam.
Have a nice day, madam.
Madam.
You too. Have a nice day. Yeah.